For this lesson, we're going to build upon our previous lesson on trigonometry and look at some sum and difference and half and double angle formulas in trigonometry. There was a question posed when you are finding the exact value of, let's say, something like the cosine of 3 pi over 4, right? The first thing that we want to do here is convert our angle into degrees. So we're going to do that by multiplying by 180 over pi. Pi's cross out. 180 over 4 results in a 45-degree angle. So we get 3 times 45 for an angle that measures 135 degrees. Now 135 degrees drawn on an XY axis is going to produce an angle in the second quadrant, like so. So this angle here measures 135. And what we're looking for right now is the measure of this reference angle made with the terminal side and the closest x-axis. And that's going to put it right there. In order to find this, because this is in quadrant number 2, 180 minus our 135-degree angle gives us a 45-degree reference angle. So there was a question posed in class, which is that it seems like all of the reference angles that we see are 30, 45, and 60 degrees. And that's true up until now. When we're looking for a 45-degree reference angle value, remember we can use the special right triangles that measure 45, 45, 90 with sides of 1, 1, radical 2. We can look at the 30, 60, 90 right triangles with sides of 1, hypotenuse 2, and side of radical 3. Or we can look at this chart here, which builds out according to this. 1, radical 2, radical 3, divided by 2 each. And then radical 3, radical 2, and 1, counting down for the cosine values, again each divided by 2. And then if we look at tangent, which is equal to sine over cosine, then we can take the numerator of sine and cosine and put it on top of one another. That's going to be 1 over radical 3. That's going to be 1, because this is equal to radical 2 over radical 2. And anything over itself is equal to 1. And then we're going to have radical 3 alone, because that's radical 3 over 1. Excuse me. So looking at this chart, we can see that the cosine of 45 degrees is equal to radical 2 over 2. As we are looking at our values, we had cosine of 3 pi over 4, which is equivalent to the cosine of 135. Then we can replace 135 with 45, but because this is in the second quadrant and we are looking and using the cosine function, all students take class ASTC tells us that this answer is going to be negative. All right, because this answer is going to be positive or negative based on the quadrant and the trig function we're using. We're going negative in this one. So we have a negative value of radical 2 over 2 as the cosine of 3 pi over 4 radians. So let's look at another one. Excuse me. Let's look at the cosine of 13 pi over 12 radians. Again, we're going to multiply by 180 over pi in order to turn this into a degree measure. 180 divided by 12 is going to be 15 over 1. So what we get here is 13 times 15, which is equal to a measure of 195 degrees. An angle starting over here on the positive x-axis swinging past 90, past 180, 195 is going to sit in quadrant 3. And the reference angle here, 195 minus 180, is equal to 15 degrees. So we have the cosine of 195 equal to the cosine of 15 made negative or positive. Quadrant 3, cosine is negative. So now we're looking at the negative cosine of 15 degrees as the answer to the cosine of 13 pi over 12. But look, our only reference angles are 30, 45, and 60 degrees. We don't have anything else. So how can we answer this? We can answer this by using a set of formulas called the sum and difference identities. You can pause it here and copy down these formulas. I will just highlight a couple of things. The sine of A plus B is equal to this formula here. Notice there's a plus sign in between. That's sine, cosine, cosine, sine. Let's jump to the cosine formula, A plus B. It's going to be cosine A, cosine B. There's a minus sign here for the sum of the two angles. It's a little nuance to be careful of. And then there's also a set of formulas for tangent. So if we are looking for the cosine of 15 degrees, using a combination of these angles over here, 30, 45, and 60, we can state that the cosine of 15 degrees is equivalent to the cosine of 45 minus 30, because 45 minus 30 is equal to 15. We still have this negative from our quadrant, so we're just going to leave that there in front. But following this formula, now we are using the cosine A minus B formula because we're looking at the cosine of 45 minus 30. That's going to be the cosine of A times the cosine of B plus the sine of A times the sine of B. So if we look at our 45 minus 30 and A is equal to 45, B is equal to 30, this is the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. And remember, there is a negative in front of there. So that means there has to be a negative in front of here. That's this negative becoming that negative right there. That's not part of the sum and difference formula. That's just coming from the problem that we're looking to solve. So the cosine of 45, then again, this chart tells us the cosine of 45 is equal to radical 2 over 2. The cosine of 30 degrees is equal to radical 3 over 2. Sine of 45 is radical 2 over 2. Sine of 30 is 1/2. So let's plug in all of those values. We're going to have radical 2 over 2 times the cosine of 30 degrees, which is radical 3 over 2, plus sine of 45, radical 2 over 2, and the sine of 30. Once again, there's a negative in front of here, so let's do this multiplication and then combine like terms. That's going to be radical 6 over 4 plus radical 2 over 4 with a negative, which is equal to radical 6 plus radical 2 divided by 4. Because the denominators are the same, we can add them together. And then we can distribute this minus sign, so negative radical 6 minus radical 2 divided by 4 is our answer. Excuse me. And that is an example of using the difference formula for the cosine function. And so let's look at another one, the tangent of 17 pi over 12. Convert this into degrees first. Once again, 15 over 1, pi's cancel out. So 17 times 15 is equal to 255. 90 up here, 180 over here, 270 down here, another quadrant 3 angle because it's somewhere between 180 and 270. So that's going to be 255 minus 180, and this is equal to a reference angle of 75 degrees. So again, tangent of 17 pi over 12 is equivalent to the tangent of 255, which is also equivalent to the tangent of 75. Is this positive or negative? Because we are in quadrant 3 and using tangent, this answer is going to be positive. So how can we rewrite 75 degrees? Again, using a combination of any of these numbers here, either subtracting or adding, because again, these are the reference angles that we have to work with. 75 is equal to 30 plus 45. And if we look at our tangent function, the sum of two angles inside a tangent function, that's the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. So that's going to get us here, the tangent of 30 plus the tangent of 45 divided by 1 minus tangent 30 times the tangent 45. Looking at our chart, we have the tangent of 30 is equal to 1 over radical 3. Tangent of 45 is equal to 1. So we can plug in those values. Tangent of 30, that's going to be 1 over radical 3 plus 1 divided by 1 minus 1 over radical 3 times 1. Adding on the numerator, multiplying by radical 3 as a common denominator, that's 1 over radical 3 plus radical 3 over radical 3 divided by 1 minus 1 over radical 3, which is just this multiplication right there. So that's equal to 1 plus radical 3 over radical 3 divided by, once again over here, radical 3 over radical 3 is our conversion for a common denominator. That's going to be radical 3 minus 1 over radical 3 after we turn this into radical 3 over radical 3 and then combine the fractions together. This is a complex fraction. Complex fraction is division. So this is 1 plus radical 3 over radical 3 divided by this, which is the same as times its reciprocal, keep, change, flip, radical 3 over radical 3 minus 1. We can cross cancel because of multiplication. 1 plus radical 3 divided by radical 3 minus 1 is your final answer. Some publications might write this differently by rationalizing this denominator, but in my class you don't have to. So that's an example of a sum formula. And again, if you're using sine function, you can use a plus b or a minus b, depending on whatever you need. Find the reference angle, and then you should be able to combine any two of these angles to get that reference angle accordingly. I hate nerds just because I'm dumber than them. They think they're smarter than me. Let's look at the double and half angle formulas now. We have two more examples here, one for the double angle, one for the half angle. Let's look at the half angle formula. Find the sine of 112.5 degrees. Right? 112.5 is a very funny looking angle, just because it might be a decimal, but 112.5 times 2 is equal to 225. Right? A 225 degree angle is a quadrant 3 angle with a reference angle of 45 degrees. So if we look at the sine of 225 over 2, we can look at this formula right here, the square root plus or minus the square root of 1 minus the cosine of 225 divided by 2. And the cosine of 225, if we do this on another page, the cosine of 225, again, is a third quadrant, reference angle of 45 degrees because 225 minus 180 is equal to that. So we look at the negative cosine of 45 degrees. That's going to be negative radical 2 over 2. So in here, we can replace this equal to plus or minus 1 minus radical 2 over 2 divided by 2. That's inside of a square root. And cleaning this up is going to require a couple of things. First, a common denominator up here of 2 on both top and bottom. So that's going to be plus or minus 2 over 2 minus radical 2 over 2 divided by 2. That's the radicand of this radical. And that's going to equal 2 minus radical 2 over 2 divided by 2 yet again, plus or minus inside the radical. Complex fraction, once again, keep, change, flip. That means numerator divided by denominator, or rather numerator times the reciprocal of the denominator. So inside the radical, that's going to be 2 minus radical 2 over 2 times 1/2. And again, this is the radicand. So that's going to be plus or minus 2 minus radical 2 divided by 4. Because we're multiplying the numerators and the denominators. So plus or minus 2 minus radical 2 inside a square root. Inside a separate square root, we can separate the numerator and denominator separately and settle upon our answer of plus or minus radical 2 minus radical 2 on the numerator and plain old regular 2 on the denominator. Now, we can't have two answers. Now, is this positive or negative? Now, we're looking at the sine of 112.5 degrees. And since that is an angle in the second quadrant, that means our answer is equal to just regular positive radical 2 minus radical 2 divided by 2. All right, now let's look at a webwork problem. Given that theta, or alpha, is in quadrant 2, tangent of theta is equal to negative 3 over 2. Let's give an exact answer for the following pieces. First thing we want to do here, right? This alone is a standard regular trig problem. We have a quadrant 2 angle. So let's draw a terminal side in quadrant 2, right? And that's going to be alpha right here. Do I know the measure of it? Not really. And quite frankly, we don't need to, right? This is the reference angle. The reference angle is always made with the terminal side and the x-axis, and we can draw ourselves a right triangle right there based on that diagram. And here's what we know. We know that this side measures 3. That's the opposite side. We know that this side measures 2, and that's because of the TOA. In SOHCAHTOA, tangent is equal to opposite over adjacent. Right? The reason why it's negative is because we're looking at a tangent function in the second quadrant. So a quick round of 3 squared plus 2 squared equals r squared gives us 9 plus 4 equals r squared. 13 equals r squared. That means r is equal to the square root of 13, technically plus or minus, but we don't look at minus sides over here. So this is equal to radical 13. So here's our reference angle. And let's draw this triangle bigger. 2, radical 13, and 3. From this reference angle here, this is the opposite side. This is the adjacent side down on the bottom, and radical 13 is the hypotenuse. Because we are in the second quadrant, that means that sine is positive, cosine is negative, and tangent is negative. That's something to know later on when we are trying to determine these values. This is going to help us determine these. Now, the sine function has a double angle formula, which is that the sine of 2a is equal to 2 sine a cosine a being our reference angle. So the sine of a is equal to 3 over radical 13. That's the opposite over the hypotenuse. The cosine of a is equal to negative 2 over radical 13. That's the adjacent over the hypotenuse, made negative because cosine is negative in the second quadrant. So now we can just plug in the values that we know. That's going to be 2 times 3 over radical 13 times negative 2 over radical 13. Multiplying the numerators together, 2 times 3 times negative 2 is equal to negative 12. Multiplying the denominators, that's the square root of 169. That's going to be negative 12 over 13 because the square root of 169 is equal to 13. Let's look at the cosine function. The cosine function has a formula. It has 3 different formulas, and you can pick either one you want to. I chose the cosine squared a minus sine squared a version. Right? Again, we already calculated that the sine of a is equal to 3 over radical 13, and the cosine of a is equal to negative 2 over radical 13. So let's go ahead and plug in. That's negative 2 over radical 13 squared minus 3 over radical 13 squared. Squaring the numerator and the denominator gets us 4 over 13. Squaring the numerator and the denominator gets us 9 over 13. Again, this 13 comes from the square root of 169. We have a common denominator, thankfully, so we can go ahead and subtract the numerator numbers and keep the same denominator. Negative 5 over 13 is your answer here. Last up is the tangent double angle formula. That's going to be 2 tangent of a on top, 1 minus 2 tangent squared a on bottom. And tangent of a, we didn't really need to calculate because remember the problem gave it to us, negative 3 over 2. So let's go ahead and plug right in. That's 2 times negative 3 over 2 divided by 1 minus negative 3 over 2 raised to the second power. Twos cancel out, so the numerator is equal to negative 3. On the denominator, that's 1 minus 9 over 4. That's negative 3 over 2 times negative 3 over 2 for a positive 9 over 4. Common denominator, in order to subtract, we're going to get negative 3 on top, 4 over 4 minus 9 over 4 on the bottom, negative 3, divided by negative 5 over 4. Complex fraction means we can keep, change, flip. Keep negative 3 over 1, change to multiplication, and flip that second fraction, get the reciprocal, so negative 4 over 5 over here. And multiply this together, so the numerator is negative 12, the denominator is equal to 5. I just made a mistake. That is a positive 12 because we're multiplying a negative times a negative. So this is our answer, 12 over 5. Thank you for watching, and good luck studying.